I'm going to draw this. For A, point A, I'm going to draw direction north, south, east, and west. I'm going to draw that. Okay. And so when it says it's going 130 degrees T, what that means is really the true bearing. Here's the thing, true bearing, 130 degrees. This may look familiar, but like, oh, I know how 130 degrees goes. It's about half a circle, not quite half a circle, because a half a circle would be 180. You're right. But with true bearings, you always start north. Okay, that's the one trick. Okay, so you always start with north. North is essentially where your degrees is. Okay, so for true bearing north, maybe that has to do with like, where the North Star is. Yeah, I don't know. Okay, anyways, so true bearing north, 130 degrees. So let's think about this for a second. If I go this much, that's 90 degrees. If I go this much, that's 180 degrees. So 130 degrees approximately, I'm just going to draw a diagram for our purposes. 130 degrees is going to be what? Like somewhere here. So it's going from here to like somewhere here, which is 130 degrees. And it's going to point B. And it is 30 kilometers to point B. So there's a distance, 30 kilometers to point B. Okay, so I'm going to actually label this. I'm going to label this 130 degrees. Right here. Let's do that in, why don't we do that in pink? That right there is 130 degrees. Now we'll come back to this in a little bit, okay? I'm just trying to create a diagram here. Then here's the second part, and it's 30 kilometers from A to B. Cool, got it. This part is done. Now the second part, if I may erase that. The second part of this problem. Okay, well, now what does it do from point B? Because obviously we're doing triangles here. If we're doing law of sines, law of cosines, it has to do with a triangle. So then from B, it sails at a bearing of 260 degrees, true bearing, or 60 kilometers to point C. Okay, so we're going to do something for B now. All right, I'm going to draw north, south, east, west, and let's see, it goes 260 degrees true bearing. So for true bearing, again, I'm going to start north where my 0 degrees is. So I'm going to start at, so let's think about where 260 is going to be. That's going to be, so this is going to be 90, 180, 270. So that's where 270 is. I don't want 270, I want 260. So 260 is going to be right below 270. I'm just estimating here. Something like that. All right. So this from 0 to there, again, let's do this in pink. From 0, okay, the pink has black marker on it now, so now it's just, all right, anyway. From 0 to there is 260 degrees. So what the direction is now, it's going at 260 degrees true bearing. So from 0 to there, 260. And how much is it? That is 60 kilometers. So it is going 60 kilometers and it's going to point. Cool. You guys see the triangle yet? Yeah, should. The triangle now would be this. I'm just going to now connect. I'm going to now connect this. Now we have a triangle. The question is asking you now, what is AC? Find AC. But the way it'll actually state it, okay, and the way it might state it, the way I would actually kind of write this problem out is, how far away is that boat? Now, if the boat is at point C, now how far away is it from its original starting point? Well, its original starting point is A. From A to C, that's the X. All right, let's analyze what we can do here. Let's look at law of sines first. Law of sines, you need to have, like I said, remember, you have 3 of these things and missing 1. So either have both sides, one of their angles, or have both angles and one of the sides. But for this, we have a problem here, because we have these external angles here, a few of these external angles, but we don't have the internal angles just yet. We have 2 sides here, cool. But in order to use law of sines, we need to have the angle for this, and we do not. Actually, we don't have the angles for anything right now. So since we don't have the angle measures for any of these, angle A, B, or C, we don't have it for any of them. We actually can't use law of sines or law of cosines right now. So it's actually, we're not quite even ready for either one of them. So let's analyze this a little bit further. Okay. If I want an angle measure, well, what am I going to do? If you notice what's happening here, guys, is I left these north, south, east, west lines, the horizontal and vertical lines. I left them there. Why? Think back to geometry for a second, if you will. In geometry, when you have two parallel lines, because again, east and west are same direction, they're parallel lines, and they're cut by a transversal. Okay, which you remember is same side interior, alternate exterior. Remember all that? Okay, so if this is like 120 degrees, this angle, alternate interior is equal to each other. That's 120. This has to be 60 because it adds up to 180. So then this is also 60 degrees. Alternate interior is they're congruent to each other. Okay, 60 degrees. So just that idea from geometry. Okay, this is where we're going to be using from geometry. Okay, so now let's take a look. I have the east-west line here. I have the east-west line here. This whole thing is 130. That's cool, but what that tells me, if the whole thing is 130, if this is 90, guys, right here, from north to east, well then 130 minus 90 is going to leave me with 40 degrees. So if that's 40 degrees, here's what that tells me. You guys see the east-west line and the east-west line. If this is 40, alternate interior right here must also be 40 degrees. So if this is 40, guess what? So I'm just going to continue doing this. If this is 40, then this is 50 degrees. Wow, look at that. 50 degrees. If that's 50 degrees, alternate interior right there, okay, is also going to be 50 degrees. Well, we already knew that because if this is 40, next to it has to be 50. These are complementary. They make 90 degrees. See that 90 degrees right there? Okay, that's cool. I know that's 50. I don't know what that is just yet. Okay, I don't know what this angle measure is right there. But I did get more information, so I got a little more filled up here, but not everything just yet, because I actually don't have any of the angles yet. I don't have angle A because it's 50 and this. I don't have angle B right here because it's 40 and this little guy right here. That's a small little angle. I just don't know how much it is yet. So let's go to this. 260 degrees. Well, think about this. If from here to here is 260, and we know that north to east is 90, and then all the way to south is another 180, and then all the way to here is 270 because it goes 90, 180, 270. If north all the way to west is 270 and this one is 260, well, what's 270 minus 260? 270 minus 260, 10. So this little guy right here is 10 degrees. Now, why is that so significant? Because ding, 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 we just got the measure of angle B. So the measure of angle B is going to be 40 and a 10, which is 50 degrees. So this is the part. I'm going to erase this and put 50 degrees. Okay, guys? So I'm just going to erase all this and just put 50 degrees. All right. So that did it right there. We're at 50 degrees right now, which is beautiful. Okay? So now, what are we going to do with this information? Now we're actually going to solve the triangle. Okay? You want me to solve the triangle? Let's do this. I am going to erase all the other unnecessary stuff. Okay? Actually, instead of erasing that, I'm going to recreate this triangle. I'll draw it neatly over here. Okay? I'm going to draw it as neatly as I can. A, B, C. And let's see, what do we have? We know A to B, this is 30. This is 60. We know this is 50 degrees. And we are looking for X right here. Okay? So does that look cool, everybody? Now, I'm going to label here angle A, side A. Angle B, side B. Angle C, side C. I cannot do law of sides because in order to have law of sides, I need to have at least one angle and side that correspond with each other. I do not have that because I'm missing the whole thing. Oh, that hurts. Oof, I think I hurt myself. It's okay. It's all right. I'll let you guys know if we need to call the paramedics. Okay, so angle B, side B, angle A, side A, and so on and so on. And I just don't have that set right there of angle and side. So I'm going to be looking at law of cosines. Now I'm looking for B. Now the law of cosines that I wrote starts with A squared. It's okay. Remember, it's interchangeable. So if I want to do it for B, it's going to look like this. B squared equals A squared plus C squared. And you could just look at your cheat sheet. Minus 2AC cosine of B. Okay, so now I'm just going to plug that in. B squared, which is that, equals A squared, which is 60 squared, plus C squared, which is, in this case, 30 squared, minus 2 times AC, which is 60 times 30, and then cosine of B, and cosine of 50. That's cosine of 50. Let's figure out what the cosine of 50. Well, let me just write it out. Cosine of 50. Okay, so we have B squared equals 60 squared is 3,600. 30 squared is 900. Okay. Minus, that's going to be 2 times 60 times 30, which is going to be, let's see, 3,600 it looks like. Okay. Let me not make any mistakes. Let me make sure we're doing this correctly. I do not trust myself. 60 times 30, okay, yeah, 3,600. And then we need the cosine of 50. So let's find the cosine of 50. That's going to be the cosine of 50, which is 0.64, roughly 0.64. 0.64. So now I'm going to do, again, I'm estimating that, okay? 0.64 times 3,600 is 2,304. So 3,600 plus 900 is 4,500. So I need to do 4,500 minus 2,304, which is equal to 2,196. Well, that's B squared. B squared equals to 2,196, so I just need to take the square root of that. Square root of 2,196 is 46.86. So we just got this. It's approximately 46.86 degrees. Whew! I know that was a lot, but we got it. We did it. We got 46.86 degrees.